Hey guys, welcome back. This is part 2 video for exercise 5.4 where we extend the range of trigonometric functions that we are able to integrate. We can integrate basic functions like cosine ax plus b, sine ax plus b, and sec squared ax plus b. And we learned at the beginning of this exercise in the previous video that what we want to do is to try to get a trigonometric function into one of these three so that we can integrate them. Okay, well let's apply that knowledge to this example of a definite integral here. So my first step, of course, is going to be to expand the bracket. When I do that, I get 1 plus 4 sine x plus 4 sine squared x dx. So far so good. I can integrate the first two terms of this, but this I can't. However, if I look at my rules over here, identities and some double angle rules, I can use this double angle rule here. So I'll show you what I'm going to do. I'm going to say cosine 2x. I'm going to use this here, and instead of using a, I'm just going to use x. So cosine 2x is equivalent to 1 minus 2 sine squared x. Now I'm going to pull my 2 sine squared x over to this side so that I get a positive value, and I'll move the cosine 2x across to this side. So I'll get this. Now you can see that I've got a 4 over here, so I need to multiply by 2 to make that 4. So I multiply both sides by 2 and I will get this. Okay, and now we are able to simply take this and shove it there. Now when we do that, our next line will look like this. I can add this 2 to the 1 that I've already got here, so I'll end up with 3. 4 sine x will stay the same, and I'll have minus 2 cosine 2x here, dx. And now we're going to use our big double brackets, our big square brackets. This 3 becomes 3x when I integrate it, and the 4 sine x will become 4 times, now we're looking over here, minus 1 over a. Well, a in this case is 1, so it's just going to be 4 times negative cosine x. And then the next bit, minus 2 times 1 over a, so 1 over 2 sine 2x. And then at the end of our brackets we'll have our limits there. Okay, so I can simplify this to 3x minus 4 cosine x minus sine 2x between 0 pi. Now when I chuck this into my calculator, I'm going to go, well, it'll be 3 pi minus 4 cosine pi minus sine 2 pi. So I'm just going to quickly chuck that in now. 3 pi, make sure you're in radians by the way, 3 pi minus 4 cosine pi minus sine 2 pi, and I get for this 13.424. So I'm just going to save that unrounded value into my calculator. I'll just do it to there for now. Okay, I'll store that there. Minus, now what have I got when I chuck in 0? Well, 3 times 0 is 0, so I'm going to have more, minus 4 cosine 0, which is going to be minus 4, minus, and we know that sine 0 is 0, so that's just simply going to be minus 4. And so our answer to 3 significant figures will be 17.4. Okay. Well, have a go at these other ones. Make sure you email me if you're having any trouble with them. But just remember, the key thing you're trying to achieve here is making sure that you're getting the trigonometric function that you're dealing with into one of those three forms that you learned how to integrate in the previous exercise. Alright guys, good luck with this. See you next time.